Alright, a horizontal particle of mass 5 kilograms lies on a smooth horizontal table, is connected by means of a light inaccessible string passed over a smooth light pulley at the end of the table to a second smooth pulley of mass 1 kilograms which is hanging freely. Our second pulley passes another light inaccessible string carrying masses 1 kilogram and 3 kilograms as shown. So we'll call this T, tension in the first string. We'll call this S, which is tension in the second string. Now my S's look like 5, so actually won't call it S. I'll call it X. Okay. Now, remember there's 1G down here, 3G, 1G. Alright. The system, the two of these will have an acceleration of, for argument's sake, let's call it A. The 5 kilogram mass has an acceleration of A. This means the 1 kilogram mass has an acceleration of A, but the 3 kilogram and the 1 kilogram mass, they have an acceleration of B if they're in isolation. Imagine this was just a question and it was in isolation. 3 kilogram mass will go down with acceleration B, while the 1 kilogram mass will go up with acceleration B. Is that okay for everybody? Now, we're going to start off nice and easy with some easy marks. Let's start off with the 5 kilogram mass. Well, F equals ma, or ma equals F. 5a equals T. Happy days. That's easy money right there, right? So 5a equals T, and that is the contribution from the 5 kilogram mass. Okay. Next we're going to look at this one. Now, the 1 kilogram mass is an interesting one. Okay. It gets pulled up by a tension T, but it gets pulled down by two S's. And we're going to say that its acceleration is going downwards. So we're going to say that 1a is equal to 2s, which is going downwards. Take away the t, that's going upwards. Because overall, this is going downwards. Down is bigger than up. Okay, that's that one done. Next one we're going to look at is what's happening to the 1 kilogram mass, which is this guy here. Now, its acceleration, it depends on whether you think it goes up or down overall. For argument's sake, it's going up at acceleration B, but down at acceleration A. For me, that's up beaten down. For another person, they'll say down beats up, which is okay as well. They'll say it's A minus B, and that's A okay. It's 1 kilogram. Okay. Now, in the case where up beats down, you're talking that X, which is the tension going upwards, beats the 1G going downwards, and in the other interpretation, you would have the 1G going down beating the X going upwards. One of them is essentially the -1 version of the other one, so it doesn't matter which one you choose. Okay, is essentially what I'm trying to get at. They're both the same formula at the end of the day. So what we're going to have here is B minus A equals X minus G. Alright, so that's for the 1 kilogram mass, which we will... Oh, by the way, it's not S. I forgot. It's X. I never used S because it looks too much like my number 5. So I'm gonna go for X. It's 2x minus t. My fault. Okay. Now, next we're going to go on to the 3 kilogram particle. The 3 kilogram particle is going downwards because A and B are both going downwards, and this means there's only one interpretation possible. It's that 3G is much more than the tension going upwards. So we get 3A plus 3b. Is that right? 3a plus 3b? 3a plus 3b equals 3g minus x. Now these things can always be a bit on the tricky side. Wouldn't mind getting rid of x, to be honest. X would be a nice one to get rid of. So I'm going to say that 2x equals a plus t. Now in the first equation I have two equations here, and I'd like to get rid of the x values pretty quickly. So these two equations here, I'm going to multiply them both by 2 to begin with. So 2b minus 2, now I use a different colour. 2b minus 2a equals 2x minus g. But we know that 2x is a plus t minus g. And we also know that t is 5a. So that's going to be 6a on this side. Bring it over to your side. It's going to be 2b minus 8a equals minus g. That's going to be one equation. I think I made a mistake here. I didn't multiply the g by 2, so it's 2g, isn't it? Jeez, I'm finding them early today. You're 2g. Alright. We're going to do the same trick with this one. It's going to be 6a, 6b. I don't like fractions. They don't like me. Some of you guys love fractions. A bit too much so. Once again, 2x is minus a minus t. So it's minus a minus t. And we all know that t is 5a. So we'll even just shade that out for 5a there. Now this is going to be an interesting one, because I'm going to have minus 6a on the left, which will give me 12a plus 6b equals 6g, and then divide by 6 and I get 2a plus b equals g. I'm just going to multiply this equation by minus 2, so it's going to be minus 4a minus 2b equals minus 2g. And I think I've coughed up an error somewhere. I'm going to have to find it. Hooray. And yes, found my error. And it's an error I tend to make quite a lot, I have to say. So, do you remember the 1 kilogram particle? This one here. Right, this one here, the 1 kilogram particle. Now here's the issue of the 1 kilogram particle, and I always forget it. I always treat it as massless, and this is a mistake I tend to make a lot. Alright, you guys don't though, you guys are great. 1g, straight downwards, okay? And then we got the two x's going downwards as well. And we have the t going upwards. So, on this formula here, what there should have been was there should have been a g plus g there as well. So there should be a 2x plus g take away t. So then when we isolate 2x, it should be a plus t take away g. So keep forgetting to take away g. So when we subbed in this 2x here, which is a plus t, there should have been another minus g there, and that would give that minus 3g. And then on this side here, it should have been 2x which was minus a minus t plus g. So it should have been a plus g over this side, and that should have been 7g. So I'm actually left with these two equations here now. Hoping this will work out okay. Oh, excuse me. Now, here's what I'm going to do. I'm going to write this as minus 8a plus 2b equals minus 3g. I'm going to multiply this by minus 3. So I'm going to get 24a minus 6b equals, I don't know, 9g, is it? 36a equals 16g. 16 divided by 36. 4 over 9. And lucky for me, 4 over 9 is the correct answer. So a equals 4g over 9. Okay. Now, the system's distance from S5 is 1 meter from the edge of the table. So this guy is 1 meter from the edge of the table. Absolute hooray for this question. Once again, this guy is insane. 1 meter from the edge of the table. Find the time it takes for the 5 kilogram mass to reach the edge of the table. Well, that's not so bad. I know the acceleration. So we're going to UVAST this bad boy. UVAST. U is 0. A is 4g over 9. S is, what's it? What do you say? 1 meter, was it? 1 meter. We're going to find out what the we're going to find the time. We're after t. So S equals ut plus a half at squared. 1 equals a half of a. Half of a is 4g over 9. T squared. Run out of time here because my kid is going to be downstairs in a second for his late night bottle. Which is, oh crap, I'm totally out of time. T squared equals 9 divided by 2g. And we square root that. Give me a sec. Sorry guys. Alright, so here's hoping. 9 divided by 2 times 9.8, because that's what gravity is. And yeah, 45, square root that. Root answer. T is 0.6778 to be honest. Right, and that is the correct answer. Thank God. It says 677, but it's actually 678. Find the speed of the 5 kilogram mass as it reaches the edge of the table. Oh, thank God, that's an easy one. P equals U plus AT. So, V equals 0 plus, what's that, 4G over 9. Sorry, 4G over 9 times 0.678. We know that G is 9.8. So just lop that into the calculator. 4 times 9.8. Divide that by 9. Multiply the answer by 0.678. 2.95 lads, and that is me done with this question. So that is question 4A. Too late for me to do 4B to be honest.